Hello friends, so here is another question. So it is given that on a 60-kilometer track, a train travels the first 30 kilometers with a uniform speed of 30 kilometers per hour, and how fast it has been asked it must travel for the next 30-kilometer phase so as to average 40 kilometers per hour for the entire trip. So how fast it must go for the next 30 kilometers so that the average speed for the entire journey is 40 kilometers per hour. Okay, so here the basic formula for average speed total distance by total time. Okay, so here the journey is divided into two phases. So it is, let's say, S1 the first phase, S2 the second phase, the distance in the first phase, the distance in the second phase, then the time in the first phase, the time taken to complete the second phase. Or we can rewrite it as S1 plus S2 by time T1 is distance S1 by velocity in the first phase V1 plus distance S2 divided by speed or velocity, sorry, speed, okay, speed V2, not velocity, speed, okay, because it has not been given whether the track is straight or not, so displacement doesn't come into play. So distance, so speed, okay, distance, speed. T1 is S1 by V1, T2 is S2 by V2. We know time is equal to distance by speed. This speed is equal to distance by time, so time is equal to distance by speed. But here you see in both the phases the distance covered is the same, 30 kilometers, 30 kilometers. So S1 is equal to S2 is equal to, let's say it is S, which is equal to 30 kilometers. So we can rewrite this equation as S plus S by S by V1 plus S by V2, okay, which is equal to 2S by S into 1 by V1, 1 by V2. I am doing all this to simplify the formula, okay, so that we can directly use the speeds and get the result. So here SS gets cancelled. This is equal to 2 by V1 V2 LCM, which is V1 plus V2, which is equal to finally 2 V1 V2 by V1 plus V2. This is the average speed. It has been given that in the first phase the velocity is 31 kilometers per hour. That is, speed in the first phase V1 is 30 kilometer per hour and the average speed required is 40 kilometers per hour. The average speed required is 40 kilometers per hour. So it is equal to 2, we'll substitute the values into 30 into V2 by 30, V1 plus V2, which is unknown, is equal to 40, this one, okay. That implies 60 V2 is equal to 40 into 30 plus V2. That implies 60 V2 minus 40 V2 is equal to 1200. That implies 20 V2 is equal to 1200. That implies V2 is equal to 1200 by 20, which is equal to 60 kilometers per hour. So the train must travel with a speed of 60 kilometers per hour for the next 30 kilometers, that is the second phase of the journey, so that the average speed for the entire journey, for the entire trip, is 40 kilometers per hour. So the speed for the second half, that is the second 30-kilometer phase of the journey, it should be 60 kilometers per hour. This. Okay. So here is another question. So it is given that a car is traveling in the positive x direction at 20 meters per second, and it needs to pass a truck, in front of it. So the velocity of the car is increased to 25 meter per second in the duration of 2 seconds. Okay, find the average acceleration of the car. So first, the basic formula of average acceleration. It is final velocity minus initial velocity divided by the time interval, that is final time minus initial time. Change in velocity divided by change in time, the time interval, time duration. Here the final velocity is 25 meter per second. Initial velocity is 20 meter per second. And this increase in velocity, it happens within a time duration, time interval of 2 seconds. So delta t is 2 seconds. So here it is 5 by 2 meters per second squared. So it is 2.5 meter per second squared, and it is positive because it has been given the car is traveling in the positive x direction. Now I have already said the sign convention to the right in the positive x and towards up in the positive y, it's positive, everything else is negative, that is towards the left and downward side it is negative. So the acceleration here, the average acceleration here is plus 2.5 meters per second square, because the velocity is increasing. The velocity is increasing in the positive x direction. 20 to 25, it increased. If it would have decreased, then it would have been deceleration or negative acceleration. Okay.